We have a question from the Chinese university entry exam in 1983. This question is not a crazy hard one, but it's not trivial either. So we're given that a is an integer and a squared over a plus 1 is also an integer. We want to find out the value of a. In other words, a squared over a plus 1 may not always be an integer. If it's a non-integer, then we're not interested. We're only interested if it turns out to be an integer, and we want to find out the value of a as an integer that satisfies this condition, that makes it an integer. So first method, I'm going to use the completing the square. So the original expression equals a squared, a plus 1 squared, minus 2a minus 1 over a plus 1. Right, so that's a squared plus 2a plus 1 minus 2a minus 1. Still the same thing. Right? So I can just simplify it. Becomes a plus 1. And I just extract minus sign out here. Minus a plus 1. On top I have 2a plus 1. And that is equal to a plus 1 minus a plus 1 at the bottom. I also want to make a plus 1 appear at the top. So further simplify that. So 2 bracket a plus 1 bracket. Right? If I expand it, I have 2a plus 2. I have the minus 2 to make it the same expression. I have to plus 1 here. So minus 2 plus 1. I have minus 1 here. So it's still the same thing. Right? So that is equal to a plus 1. A plus 1, and this and that cancel out. Minus 2. Plus 1 minus 2. That's minus 1. And I have minus 1 over a plus 1. So I have a plus 1 over a plus 1. And so that given the whole expression is an integer, right? Also a minus 1 is also obviously an integer. So that means this expression has to be an integer as well. 1 over a plus 1. So in other words, a plus 1 has to divide into 1. So the only number that divides into 1 should be 1 and minus 1. Right? There's no other number that can divide 1. So a plus 1 is equal to either 1 or minus 1. In other words, a must be equal to 0 or minus 2. Right? A plus 1 equals minus 2. So it's really true. When a equals 0, that equals 0. And a equals minus 2, that's equal to 4 over minus 1, that's minus 4. Both being integers. So really true. So the second method actually very similar to the first one. So simply let the top becomes a squared minus 1 plus 1. Then a squared minus 1, that's a difference of perfect square. Then following the similar procedures. But in the end, it turns out to be exactly the same. Right? Up to this step. So basically, the second method is no essential difference than the first one. So there is third method. So I'm going to use this lemma. It's pretty much like a Euclidean algorithm. If we're given I just write GCD without writing GCD. So just a bracket, right, denoting the GCD. Greatest common divisor of two integers, a1 and a2, should be equal to greatest common divisor between a1 and a2 plus k times a1. K can be any integer. So in other words, if we just select one of the integers, let's say a1, doesn't matter, could be a2. Here I select a1. a1 multiplied by any integer. Then I get some integer, right? Get a new integer, and I add that integer onto the other number, a2. And the new result I have between this result and A1 should have exactly the same GCD as previous. Perhaps I'll prove it in a future video, but now I'm just going to use it straight away. So in other words, if I want to find out the GCD between a squared and a plus 1, all I have to do is select a plus 1 and then multiply it by some integer and add it upon a squared. Hopefully cancel out the degree, right? Because a squared is too high of a degree. I want to reduce it. Maybe I can multiply a plus 1 with minus a, right? That way I can obtain, if it a plus 1, right, times minus a, I have minus a squared minus a, right? So I can just plus the minus a times a plus 1, right? According to my lemma, I've multiplied one of the numbers with some other integer and add that new integer onto the other number. That's this number. And a plus 1, right? Still the same effect. And now I can cancel out the a squared. So minus a squared, and I have a minus a coming out, right? Minus a and a plus 1. I just need to find out the greatest common divisor between minus a and a plus 1. And I can further simplify that. In fact, I want to multiply this number by 1 and add that onto this number. Right, just cancel out the a. Equals minus a, copy down, remains the same. And a plus 1, like I said, I multiply minus a by 1 and add on to a plus 1. So 1 times minus a. Right, now it's between minus a and, so a minus a cancel out. I have 1 left, right? So it's only need to find out the greatest common divisor between minus a and positive 1. So what's their greatest common divisor? Easily 1. Obviously 1, right? Because simply I have a 1 here, right? No matter what the value of a is, right? Because I have a 1 here. No other integer that's larger than 1 can divide into 1. Now, according to our condition, this given to be an integer, so that means a plus 1 divides a squared, right? So a plus 1 divides into a squared without any remainder at all. So in other words, the greatest common divisor between a squared and a plus 1 should be not just a plus 1, but the absolute value of a plus 1, just to be safe here, right? If a plus 1 happens to be a negative integer, say negative 3, then the GCD, right, has to be positive 3 in this case. Right? It's always positive. So this is to be safe. If it's positive 3, then it's positive 3, fine. Right? So, like I said, I've proven that the GCD between a squared and a plus 1 is exactly 1. Right? So, the GCD of a squared and a plus 1 is equal to 1, also equal to this value. So, in other words, a plus 1 absolute value is equal to 1. So a plus 1 should equal to either 1 or negative 1, right? So in other words, a should equal to, if it's 1, then a is 0. If it's negative 1, then a is negative 2. The same result.